Okay, in this video we are discussing heat and matter and the relationship between them. Basically how heat can affect the state or the phase of matter. Right, so all matter just means stuff, okay? All stuff is either solid, liquid or gas. So this solid, liquid or gas, that's the state of matter. Right, so for example H2O in a liquid state is water, right? If you freeze water, it becomes ice. It's still H2O, right? But now it's a solid. Okay, and if you boil water, it becomes a gas. It turns into steam. Again, it's still H2O. It's still the same basic stuff. It's the same matter. All that's happening is the state is changing, right? So when we talk about temperature change and state change, that's usually done by applying heat. So it says heat causes changes both in temperature and state, okay? Then we're going to discuss the different methods of heat transfer. So there's three main ways: conduction, convection, and radiation, which we're going to cover. Question: what is the process called when ice turns into water? A, freezing, B, melting, C, condensation, or D, sublimation? The correct answer is melting, okay? So you probably already knew that. We know that when you take ice out of the freezer on a hot day, it's going to melt very quickly and turn back into water, which is a liquid. So it's going from solid to liquid because of the heat in the atmosphere. Right, so all four of these are different ways or different changes of state. So all in all, there's 6 different changes of state. The first 4 you probably already know because we encounter them in daily life, right? A solid going to a liquid, that's melting, right? Water, ice cream, okay? The opposite is freezing, right? You put a bottle of water in the freezer, it will become a solid, it will turn to ice, right? Then you got liquid going to a gas. That's called evaporation, right? So that happens, that happens with, for example, with boiling a kettle, right? When you boil the water, it turns into steam. Steam is a gas. So you've got liquid water going to gas. That's called evaporation, okay? The opposite of that, a gas turning back into a liquid as it cools down, that's condensation, right? So you see that on your windows, and you can see it on the mirror in your bathroom. Let's say you take a very hot shower, right? The water turns to steam first of all. When you get out of the shower, as that steam cools down, you'll see it in the form of water droplets or condensation on the windows and your mirror, okay? Then you've got 2 more, right? These are quite unusual because usually when we talk about phase states or changes in phase or change in state, it goes from a solid to a liquid to a gas and back from a gas to a liquid to a solid, right? But in these 2, we're skipping out the middle bit. There's no liquid phase here. So a solid turning directly to a gas, we call that sublimation. And a gas turning back into a solid is deposition, right? You don't need to know more about it, but just remember the names, right? And what they are. So sublimation, solid to gas. Deposition, gas back to solid, okay? You might get questioned on that in the exam. These 4 1 or 2 or more of them will definitely come in the exam. So all in all, there's 6 different changes of state. Okay, question. Sensible heat causes A temperature change without a state change, B, a state change without a temperature change, C, both temperature and state change, or D, no change. The correct answer is A, temperature change without a state change, right? So what does that mean, sensible heat? Sensible heat is just basically the heat that that heats stuff up without changing it from a solid to a liquid or a liquid to a gas, okay? So it can either increase or decrease the temperature. The main point with sensible heat is that there's no change in phase. So what does that mean? If you heat water up from 20 to 80 degrees Celsius, you've still got water, it's still a liquid, so you're starting with a liquid, you're finishing with a liquid. That means there was no change in phase or no change in state, right? That's sensible heat. The opposite of that, when you apply heat to something and it changes, let's say from a liquid to a gas, that's called latent heat. So the two main phrases, sensible heat and latent heat, that's what you want to remember. Alright, so for example, you start off with, let's say you start off with a pot of water or a kettle. The heat that's applied to that water to get it to boiling point, that's sensible heat, right? The heat to keep it boiling, which will cause the liquid water to change into a gas, that's called latent heat. Okay, moving on, heat transfer now. Okay, so heat transfer by molecule to molecule contact is called A, radiation, B, convection, C, conduction, or D, evaporation. The correct answer is C, conduction. Okay, so A, B, and C, these are all different methods of heat transfer. Evaporation is not, right? That's a state change or a phase change. So, what's the difference between these three? First of all, let's discuss conduction. So conduction occurs by molecules passing energy directly. Okay, and the best conductors tend to be metals, whereas plastics and wood or stone are not as good as conducting as metals. Okay, so this is a copper pipe, right? It can be as long as you like, a meter. Also, if you apply heat just to one end of the copper and you're holding the other end, you're going to burn your hand quite quickly, okay? That's why when you're soldering pipes, you need to have gloves or a wet rag to protect your hand, right? Because otherwise what will happen, although you're applying the heat here, the heat is going to travel along the copper. Why? Because of the molecules in the copper, so the heat's going to transfer between molecules. And it will heat up the other end of the copper quickly because metals are good conductors of heat and electricity, whereas plastics and woods, not so much. So that's conduction, right? That's within a material, right? So you've got three main methods of heat transfer. That's conduction, which we just spoke about. Then there's convection, right? Convection happens with liquids and gases. So if you think about water in a radiator, what happens is the hot water goes into the bottom of the radiator. Because it's hot, it will become less dense and it will rise. And at the same time, the cooler water at the top will sink. So you get this kind of circulation between hot and cold within the radiator, which is filled with water, which is a liquid. And at the same time, that radiator is heating up the room. So you've got the air molecules at the bottom of the room. They get hot, they rise, and the cold air at the top sinks. So you've got a kind of circulating motion through convection. Radiation, we usually talk about radiation from the sun, and that relies on electromagnetic waves. Now the thing about that, it says it no medium required. It just goes from the source of the heat to the thing that's getting heated. It doesn't heat up the stuff in between, in this case the air. Okay, question, which material is the best conductor of heat? A, polystyrene, B, copper, C, wood, or D, plastic? Correct answer is B, copper. Why? Because metals in general, they're better conductors, right? Polystyrene, if you heat it, it will just burn, right? It won't conduct the heat. Same with plastics. And wood as well. Okay, so fun fact, silver is actually the best heat conductor, right? Obviously, because it's more expensive. We use copper widely in plumbing, and it's also a good heat conductor. Okay, when copper pipe heats up, it A, shrinks, B, stays the same, C, expands, or D, changes color. Correct answer is expands, right? So most metals, when you heat them, they will expand. Now, the reason why that's important, so first of all, we call that thermal expansion. Anytime you see thermal, that means it's to do with heat. Okay? So copper expands when heated. And this is what causes, so often customers will complain that whenever I turn the heating on, they'll say, I hear this funny noise under the floorboards or in the walls or something. What's happening is the copper pipes are expanding, and that makes a ticking sound. Okay, and the reason why it's important to know this is because when your copper pipes expand and contract, You have to allow for that expansion to happen, which means if you're making holes through things like joists under the floor, you have to leave a little bit of space to allow for that expansion. Okay, then we've got gravity circulation in hot water systems is an example of A, conduction, B, radiation, C, convection, or D, sublimation. Okay, so the correct answer is C, convection. So like I just explained with the radiator example, it also applies to hot water cylinders, right? The hot water inlet is usually at the bottom. And what will happen is the hot water will rise to the top and the cooler water will sink. So in gravity-fed systems, which you may or may not have studied yet, so you'll do that in the hot water module. The older systems, they're not pumped, right? They're served by gravity. So what will happen is the hot water will rise and the cold water will fall and it creates a kind of circulation. So that's called convection. Okay, recap. There are 6 phase changes, alright, so we did that in the previous slides. Just go back and look at that. Make sure you know what the names for all of them are at the very least, and what the state change is, right? So for example, melting, solid to liquid. Freezing is the opposite. Liquid to solid, liquid to gas. We call evaporation. Condensation's the other way around. Then you've got sublimation and deposition. Make sure you remember those. Then we have the idea of sensible heat. Sensible heat changes the temperature without changing the state. Latent heat changes the state without the temperature, okay? 3 methods of heat transfer. Conduction is usually, so think of metals and it's happening inside the same material. Convection is with fluids. Fluids can be liquid or gas. Radiation is electromagnetic waves, and the key to that one is that it heats without it. So it heats an object without heating the medium. There's no need for a medium. And then you've got the idea of thermal conductivity, with metals being the best conductors. And remember, metals expand when they're heated.